Okay, so we are going to start with maths chapter graphical representation. Okay, you know what is a bar graph? You learned this in class 8 when you have a raw data, and when you tabulate that raw data, you use ungrouped frequency distribution table. You write your observations over here, then the tally marks, and then the frequency. Now, when you represent this in the graphical form, it looks like this. Let's hear what is bar graph all about over here. It's a short video just here, so your basics will be brushed up.
Let's see a practical example where the bar graph can be used to understand data more easily. This is a graph of average temperature of various cities. In this graph, we mark 10 degrees in equal intervals. And we have been given data for 6 cities: A, B, C, D, E, and F. Now, just by looking at this graph, let's try to answer a few questions. Here's the first one. Which is the hottest city among these 6 cities? Well, it's obvious. It's city F, as its average temperature is highest among peers. Next one. If temperature greater than 25 degrees Celsius is warm, list the warm cities. This is the 25 degrees Celsius line. All cities having their average temperature above this line will be included in the list. So the warm cities are B, C, and F. Here's the last one. What is the difference in temperatures between the hottest and the coldest cities? The temperature of the hottest city is approximately 48 degrees Celsius, and the temperature of the coldest city is around 9 degrees Celsius. So the answer is 48 minus 9, which will equal 39 degrees Celsius. Apart from helping us answer such questions, the most important way in which the bar graph helps us is that just by looking at it, we get an idea about each of the categories.
Okay, now let's see what is the difference between bar graph and histogram. In bar graph, since the data is ungrouped, the bars are spaced out. There are spaces between the bars, but in histogram, as we are using grouped frequency distributions, there is no gap between the observations. They are in continuous type class intervals. Hence, there is no gap between the bars. Let's take a look at a video of histogram.
In this table, we have 2 rows. In one, we will have the class interval, which will be the price range of pens, and in the second, we will have the frequency, that is the number of pens sold of each range. So these are the different class intervals that are given. The first range is pens that cost between 10 and 20 rupees. We can see that the upper limit of one interval is equal to the lower limit of the next interval, making it continuous. As it's continuous, the first group would mean 10 rupees is less than or equal to the price of the pen, which will be less than 20 rupees. The lower limit is included, but the upper limit is not. So in the second group, 20 is included along with all numbers less than 30 but not equal to 30. In the second row, we have the number of pens sold for each category. 15 pens of this category were sold, 20 of this category, and so on. Until now, we have seen examples of bar graphs but never seen bar graphs used to represent continuous form of grouping. Let's see how we can do that. The first thing that we do is draw the x and the y axis. We draw the axis and make equal intervals on each of them. Then we label the axis. Since we want to represent the quantity of each class interval, we have the pens sold in the y-axis and the price range of pens on the x-axis. The steps are similar to the ones we used to draw a bar graph. Now we have to choose a suitable scale for the y-axis. The number of pens sold range between 5 and 30. A scale of 1 centimeter equals to 5 pence on the y-axis would be perfect, as we would need just 6 divisions. We start writing the values on the y-axis: 5, 10, 15 and so on up to 30. And on the x-axis, we start writing the price range of pens. The first range is 10 to 20, then 20 to 30, and so on up to 50 to 60. That's it. Now we just have to draw appropriate bars for each class interval. For the range 10 to 20, the frequency is 15. So based on the scale, we draw a bar of length 3 centimeters. For a frequency of 20, we draw a bar of length 4 centimeters. And we continue the process till we reach the last range. This is called the histogram. Bars used to represent continuous class intervals. Remember, for bar graphs, we did not have intervals here. We just had plain simple categories. But here, we have intervals on one axis and quantity on the other. What we did here was simple. We choose a scale and draw bars for each continuous interval. But note that the intervals were continuous. 20, which is the upper limit of the first interval, is used as the lower limit for the next interval. But what if the intervals are discontinuous? We will understand that in another video.
Okay, so this is our first question, where you have to draw the histogram of the following. Class intervals are 0 to 8, 8 to 16, 16 to 24, 24 to 32, 32 to 40. So I've chosen a scale of 1 centimeter is equal to 4 units. I'll show you on the x-axis. Each centimeter, each block is equal to 1 centimeter of length. I have marked it as unit of 4, so 4 units here, then 8, 12, 16 up to 40. So all the class intervals are over here: 0 to 8, 8 to 16, 16 to 24 and so on. Frequency, our minimum frequency is 5 and maximum is 12. So I have taken 2 centimeter as 1 unit so that my whole page will be utilized. So from 0 to 1 there are 2 blocks, then 1 to 2, 2 blocks, 2 to 3, 3 to 4 and so on up to 12, right? So just for the sake of showing you, I have drawn 2 bars already. So the first class interval is 0 to 8. So from 0 to 8 I have drawn a bar whose height is 6, okay, because of the frequency. 0 to 8, 6. 8 to 16 is 9. Okay, one more thing I will write over here is just a moment. Okay, over here I'm going to write class intervals, and here frequency, right? So class intervals, put an arrow like this, and frequency. All right, now I'm going to construct remaining bars: 16 to 24, 12. Let's do that. Now the freehand bars will be not accurate. See, my lines are not accurate, but I'll still try. Okay, so just don't mind them. You have to draw with a scale. Okay, so this is the next bar. Let me complete that. It is going right here. Okay, so this is the next bar, and after that 24 to 32, 10. Okay, 24 to 32, 10. Okay, 10 is over here. So I'll just draw a rectangle like this, and go down. In a straight line. Finish that. Okay, then next is 32 to 45, the last one. 32 to 40 is 5. Okay, so here you go, your bar graph is ready. If you want, I can show you, I can zoom out and show you how it looks like. Oops, sorry. Yeah, this is how it looks like if you zoom out, right? If you want, you can make some designs like this. Properly with a scale, okay, and it should look okay. Okay, so this is how your bar graph will look like. See, the important thing is not about drawing the bar or anything. Writing scale is most important. Okay, writing scale is most important. Uh, Writing the numbers, choosing the scale and writing the numbers properly, uh, making sure that the height is okay. So these things are important. Okay, so this is a continuous type class group frequency distribution table in which the class intervals are continuous or exclusive. So always make sure that your class intervals are exclusive type or continuous type, and then go ahead and plot the bar graph, histogram, I'm sorry. Next question. Okay, now here you see that the gap between the lower and the upper limit, that is the class width, is 50, but the first lower limit of the first class is 150. Now you generally start from 0 over here, but here directly they've given 150. Okay, so uh, let's do one thing. Let's first write the scale and then discuss. Okay, so what is going to be the scale? Scale on x-axis, 1 centimeter is equal to, okay, so on x-axis 1 centimeter, I'll take it as 50 units. Okay, on y-axis I'll keep it little small for my convenience. You can make it bigger also. I'll take 1 centimeter is equal to 1 unit. Okay, so what I'm going to do here is, first I'm going to mark the arrow over here and write y-axis. Okay, then here x-axis, here will be class intervals. So this is 0, right? So if I write 50, 100, 150, 200, 250, and so on, my bar graph will begin from here. Okay, I have to begin my bar graph from this point. So what about this space? These three blocks are wasted. So in order to minimize this wastage of space, I have one way which I want to show you. Let me first remove the numbers over here. Okay, so the numbers are removed. Now see, what I'm going to do on x-axis is I'm going to make a kink. So this is known as a break or a kink. If you put a kink, you can directly start from whichever number you like. So put a kink in one block, leave one block, and then write your whatever number you want: 150, 200, 250, 300, 350, 400, 450, 500. Okay, so let me check the question. It is up to 400 only. Great. So I've written two more number extra. No problem. Now on a y-axis, 1 centimeter is 1 unit. So it's very simple. I'll just first write on y-axis what I need to write. So here this way will be the frequency, right? So you should always mention what is your x-axis and y-axis. Now let me write 1 unit. 1 centimeter is equal to 1 unit, so 1. Okay, I'm sorry. Okay, I got this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more, last one will be 10. Okay, so I've marked it. Now this is going to be comparatively smaller graph. You can change the scale as per your convenience. Okay, just make sure that the graph should not be very small or very big. It should not require a very small area in your graph paper. It should be fairly big enough. So if I would have taken 2 centimeter as 1 unit, that could have been good. And here also 2 centimeter as 50 units. So I think most of the graph would be filled. So the scale you can manipulate as per your wish. Just make sure that your graph should look good. So the first frequency is 10. 10, 5, 7, 4, 3. Okay, I'll remember those numbers. Now let's see how to draw this. Okay, so 10. So the first tower should be this high, 10. Now let me draw a line. Okay, this is going way off. Let me try again. I can definitely try like this. Okay, just excuse my crooked lines over here. I don't have scale or anything to use on this tablet. Okay, so the first is 10, then is 5, 7, 4, 3. Okay, so next tower is 200 to 250, 5. The height should be 5. Next should be 7. So this height. Okay, and this goes down. Okay, so 7 and then 4 and 3. Two small towers. 4 is going to be here and 3 is going to be over here. Okay, so my crooked bar graph is ready. Please excuse my lines. I've already told you thrice, but I'm again telling you, you have to draw these lines. These should look like proper rectangles, towers. Okay, so be very careful in drawing them. So scale, you've understood. Kink, you've understood. This is a new thing you understood in this question. So let's go to the next question. In the next question, the first thing is the class intervals are discontinuous type or inclusive type. You have to convert the discontinuous class intervals into continuous type. For doing that, you have learned in class 9 that what you need to do is you need to take lower limit of a class minus upper limit of a previous class. I will write here lower limit of a class minus upper limit of previous class. Okay, the whole upon 2. I'm sorry for that. Crooked lines are my today's talent. Okay, sorry. The whole upon 2. So what is this? This is the adjustment factor. Adjustment factor. So adjustment factor is lower limit of a class, let's say 21 is equal to 21 minus upper limit of previous class, that is 20, the whole upon 2. 21 minus 20 is 1 by 2, that is 0.5. So what I have to do with this 0.5? I have to subtract the adjustment factor, that is 0.5, from all lower limits and add 0.5 to all upper limits, right? So if I subtract 0.5 from 10, what should it become? It should from 11 it should become 10.5. Okay, and if I add uh, 0.5 to 20, it should become 20.5. So 10.5 to 20.5. Here if I subtract 0.5, it should become 20.5 to 30 plus 0.5, that is 30.5. So I can continue now. 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5, right? So we have our new class intervals which are exclusive type. Now we are ready to plot the bar graph. I'm sorry, histogram. Please don't make the mistake of plotting the histogram with discontinuous or inclusive type of class interval. So I've just refreshed the memory from ninth. This is what we've learned in ninth class to convert inclusive type of class interval to continuous or exclusive type. Okay, so let's mark our things. Let's first I think the first thing should be the scale, right? So here let me just go up. Okay, so scale. Okay, on x-axis 1 centimeter is equal to, on y-axis 1 centimeter is equal to. Okay, so on x-axis you see that the first class interval is from 10.5 to 20.5. What is the gap? What is the class width? 10. So each class has a class width of 10. So on x-axis 1 centimeter is equal to 10 units should be okay. You can take 2 centimeter is equal to 10 units if you want to make the graph look little bigger. Okay, on y-axis 1 centimeter should be equal to, okay, now if you see here the maximum is 13 and the minimum is 5. So 1 centimeter is equal to 1 unit all over again is okay. You can change the scale as per the question. Okay, let me mark over here. This is your y, this is 0, this is x. Now one very important thing, okay, let me write our class intervals over here, and frequency will be here, right? The arrow is not straight, but please make it straight. Okay, so class intervals, frequency, scale, this is the layout. Now you can definitely draw bar graph, but let's talk more about the class intervals, right? So here the first class interval is 10.5. I have taken 1 centimeter as 10 units. Now tell me, if I write 10 over here, where is going to be 10.5? Suppose if I write 10 over here, let me zoom in for you. Okay, I'm just going to zoom in for you. View and zoom in, zoom in, zoom in, zoom in. Okay. Yes. So this is 10. This is 20. This is 30. Okay, so this is 10. You see the small tiny part over here? This is 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Okay, so there are 10 divisions. Definitely you can see them. You have to start your graph from 10.5. That is the space between 10 and 11. Now you have to zoom in further, further, further. My God, you can't zoom in further. So see, you see this tiny space? You have to start your graph from here. Is it convenient to start your graph from this point? No, it's not convenient. So we are going to manipulate our numbers with the help of very useful instrument which we have got, which is known as zoom out. No, which is known as kink. Which is known as kink. Okay. So let me just first get rid of this numbers which I have drawn, and I've written something over here. Just get rid of them. Great. So my x-axis is again empty. So what I'm going to do is, to avoid the hassle of plotting 10.5 to 20.5, I'm just going to draw a kink over here. Okay. After drawing a kink, I'll leave one block, and from here I'm going to write again. So this is going to be 10.5. This is going to be, if you want, you can make it little wider. Okay, we'll make it little wider. This is going to be 20.5, so that it does not, then it becomes so close to each other, and then you'll make mistakes, and your teacher won't give you marks. Okay, I don't want that. So 20.5 to 30.5, 30.5 to 40.5, 40.5 to, so there is a point, tiny point over here. Make it bigger. Make it bigger here as well. Make it bigger here as well. Should not look 105 to 105. Okay, 30.5, 40.5, 50.5, and this one is going to be 60.5. Okay, let's see what is the question. What does it say? Till where? Yeah, 60.5 is last. Now the first tower should be 5 high. Let me, okay, now see, after when you have taken the scale as 2 centimeter as 10 units, let me change it over here. Let me do draw eraser and just change this. Okay, I've changed it. Let me write 2 over here. Always, if you make any changes to your scale, you must mention over here. Okay, great. Now the y-axis frequency. So I have told 1 unit as 1 centimeter, 1 centimeter as 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, should go up to 13, right? So it's going to be over here 12 and 13. Okay, पहुंच गए हम लोग यहाँ पे. अब बनाते हैं ग्राफ. 10.5 to 20.5 is 5. Okay, again, okay, I don't want to embarrass myself. You know how it's going to be. The crooked lines are going to come back again. Oh, this time it was really better. Good, very nice, beautiful lines. Yeah. Okay, cool. It looks so good. So 10.5 to 20.5, the height is 5. Then 20.5 to 30.5, it's going to be 8. Okay, so this is going to be over here. 8. First draw this line with a scale, then this line over here, and then the last line over here. Right? So this touches here, and then 8, 13, 10, 6. Okay, so next is 13. 13, and then 10. 10 is over here, so this is 10, and then 6 is over here. Okay, so just finish drawing the rectangles, the towers, whatever you call them. Okay, so this is done. Oh, I'm sorry for that. That looked really messy. I'm in a hurry. Okay, so I finished. This is how my bar graph will look like with a kink. Beautiful. 10.5 to 20.5. See the class intervals properly. So the scale looks so nice, right? So you've understood how to draw a histogram. Why I'm always saying bar graph, it's histogram. Okay, I'm making mistake, please excuse me for that. Okay, so next one, you have got class mark. that is mid value, midpoint of a class, and then you have got frequency, and you have to draw a histogram, but without class intervals you cannot draw a histogram. So let's see what we can do. What we'll do is we'll take a class mark of a class, let's say 35, and we'll subtract the previous class mark from it, so minus 25. So what we are getting here, 10. So this 10 is nothing but class width. Class width, you know, class width, class size, upper limit minus lower limit. Okay, so what we are going to do is we are going to divide this 10 by 2. So we are going to get 5. So this 5 is a magic number. What we are going to do with this magic number? We are going to subtract the magic number from mid value and add it to the mid value. So when we subtract it from any mid value, we get a number which is lower limit, right? And when we add it, 25 plus 5, we get upper limit. So for every class interval you have to do the same calculation but orally. So you've got the first class which is 20 to 30, right? So next will be 30 to 40 because the midpoint is 35, 40 to 50, 50 to 60, 60 to 70. So these are all your class intervals. You have your frequencies. You can definitely go and plot the histogram, right? So this histogram, I'm not going to embarrass myself and plot it, the crooked histogram. I'm going to leave it for you. So this is solved. This is to be solved by you. Okay, next question. Great. Okay, the next question is about ogive. Some people they call it ogive or something, but it's not that. It is pronounced as ogive. Okay, ogive. So ogive, what is an ogive? Ogive is a cumulative frequency curve. Do you remember what is a cumulative frequency distribution table, or what is cumulative frequency? Okay, if you don't remember from ninth class, I will just tell you because there was a very small part of cumulative frequency in ninth class, but you need to remember that. So the cumulative frequency which we are going to study here in 10th class is less than type cumulative frequency. So what is less than type cumulative frequency? Now here you see the frequency number of students is 7. You write 7 as it is. So if I ask a question that how many students have scored marks less than 10, so less than 10, 7 students have scored the marks, okay, then this frequency gets added with the next frequency. So 7 plus 9, 7 plus 9 is how much? 16. So the valid question should be how many students have marks scored, how many students have scored marks less than 15. Less than 15 marks are scored by 16 students. 9 are over here and 7 are over here. Both are less than 15. So 9 plus 7 is 16. Okay. Uh, then you have to take 16 and add the next frequency to it, that is 12. So 16 plus 12 is 28. Then 28 plus 8 is 36. And then 36 plus 6 is what? 42. Okay, so this is what you basically mark. Uh, you take the frequency, you add with the next frequency and go on adding the frequencies, and here you get the total frequency. This is n, or total number of observations, or total frequency, that is 42. Okay, so first thing, in whenever you have to draw ogive, you have to find cumulative frequency, less than type cumulative frequency. Now what you have to mark? You have to mark points. Okay, you have to mark points. Which points you have to mark? You have to mark the upper limit of each class interval versus cumulative frequency. Upper limit versus cumulative frequency. So the upper limit are 10, 15, 20, 25, 30. They will go to the x-axis. Okay, so here I'm going to write x, and here I'm going to write upper limits. Now anyway, we are going to begin with 0 only. If it is a special case of kink, then you can begin from anywhere, but anyway we are going to begin from 0, and then the upper limits are 10, 15, 20, 25, 30. So what should be the scale? Okay, so again, scale on x-axis 1 centimeter is equal to, oh, let me just correct that. I am more comfortable with 2 centimeter, right? 2 centimeter is equal to 5 units. And what about on y-axis? See, on y-axis, um, you are having lowest number as 7, which has to be plotted, and greatest as 42. So you cannot take 1 centimeter is equal to 1 unit. So you have to take 1 centimeter is equal to, are they all multiple of 2? And can you fit in till 42? It seems little impossible, but we can try. We can definitely try, but then it's going to be too long curve to. Okay, let's try 2 units. Why not? 2 units. Okay, see, this is how you think about when you take scale. Okay, so let's write over here y. Oops, I did something wrong. Okay, I got it back. Y. Okay, so I've got my x and y axis. Upper limits are going to be on x axis, and on y axis, what I'm going to get over here, I'm going to get the cumulative frequencies. Let's write the numbers: 0, 5, 10, 15. Okay, so 0, 5. Okay, every 2 centimeter is 5 units. Okay, so that's also wrong. I have to write 5. Control Z. I have to write, oops, okay, done. So I have to write 5 after 2 blocks, 2 centimeter, right? So here it's going to be 5, 10, 15, 20, 25, 30, 35 if necessary. Is it necessary 35, 40? No, only up to 30. Oh, now comes y-axis. So it's going to be huge. 1 centimeter is 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Am I going right? Yes. 24, 26, 28. Let me finish this. I have to go up to 42, right? So this is going to be 30, 32, 34, 36, 38, 40, 42. Okay, this seems okay. Okay, now let's plot the points. What are the points which needs to be plotted? Upper limit versus cumulative frequency. What is the upper limit for the first class? It's 10. 10 versus 7. Okay, so 10 versus 7. Where is 10? Over here. And where is 7? Okay, so here, see, this is 10 and 7 should be somewhere in between. Okay, so between 6 and 8, if you see the fifth line, let me just zoom it. Okay, so 10 versus 7. Okay, this is 6, 1, 2, 3, 4 and 5. This is going to be the point which I'm looking for. Okay, every time I will not zoom, I'm just showing you it lies between 6 and 8. Okay, so I'm just going to go back. 10 versus 7. Next is okay. Next is upper limit 15 versus 16. Okay, 15 versus 16. Always in the less than ogive, it is upper limit versus cumulative frequency. 15 versus 16. So this is the line of 15 and this is point 16. 15 versus 16. Okay, whenever you draw a point, you just make a circle around it and highlight it in a very subtle way. Okay, 16 versus 15 versus 16, 20 versus 28. Okay, 20 versus 28. This is the line of 20. It meets over here. Let me draw a point over here. Okay, 20 versus 28, 25 versus 36, 25. This is the line of 25 versus 36. And last one, 30 versus 42. Okay, the last one is over here, 30 versus 42. Now I'll zoom out and show you where are these points. See, this is where they are. This is how they are. Now if you see, we are going to start from here, but never start from in between. Okay, always keep your ogive grounded. So you have to mark its base on the lower limit of that particular class, that is 5. This is your base. Okay, now what you have to do, you have to draw a smooth curve from this line to this line, this point to this point. Okay, a smooth curve. Let me go. Okay, I'm not going through that, I'm just going wrong. All over again. It should be smooth continuous curve. Okay, that's it. So this is how it will look. Of course, much more smoother than this. If this is not done, it should be much more smooth. Okay, smooth means it should look continuous and it should be a curve. This is like a broken line. Okay, anyways, but you know how to draw an ogive now. Okay, so this is cumulative frequency curve or ogive. So mostly all types of questions I have covered. If I missed anything, you can ask me doubts. I can show it that how to do it. So this was a small chapter. I hope that you've understood the concept, and I'll see you in the next video. All right, bye bye.